Good morning, students. Let us continue with chapter 11 calorimetry. In previous video, I discussed about the meaning of specific heat capacity. It is the amount of heat energy required for unit mass of substance to increase its temperature by 1 degree Celsius. And water has specific heat capacity of 4.2 joule per gram degree Celsius. It means for 1 gram water to increase the temperature by 1 degree Celsius, 4.2 joule of heat is required. Then if you know the specific heat capacity of a substance, you can make a conclusion about its conductivity. I mean, you can tell that substance is a good conductor or bad conductor if you know the specific heat capacity. A substance of high specific heat capacity, it means it requires large amount of heat to increase its temperature by 1 degree Celsius for unit mass, I mean. So large amount of heat is required means it will take time, or it is called as a bad conductor of electricity. A substance having high specific capacity is a bad conductor of heat. We are discussing about conductivity of heat. In turn, a substance having low specific capacity is a good conductor of heat. Because of low specific capacity, it requires less amount of heat to increase its temperature. Thereby, it can get heated up soon. So remember the point, a substance of high specific capacity is a bad conductor of heat, and a substance of low specific capacity is a good conductor of heat. Next topic, we will see how to do calorimetry experiments. I told in the previous video, calorimetry is an experimental method of measurement of heat energy. So we are going to discuss how to do calorimetry experiments to measure the heat lost by a body or heat gained by a body. These calorimetry experiments are mostly, or all the calorimetry experiments, we mix a cold and hot body, and from that mixing, hot body, when it is mixed with a cold body, hot body will lose heat energy and cold body will gain heat energy. So we can calculate how much is the heat lost by the hot body as well as heat gained by the cold body. And this uh, mixing of the hot and cold body is done in a special vessel called calorimeter. Calorimeter is a vessel made of copper. And this vessel is made with a thin sheet of copper. It has some reasons. I told already, in this vessel only we are mixing the hot and cold bodies. So while mixing this hot and cold body, hot body will lose heat energy and cold body will gain that heat energy which was lost by the hot body. That is the principle of calorimetry. According to principle of calorimetry, the heat, when we mix a hot and cold body, how much is the heat lost by the hot body, same will be the heat gained by the body if there is no heat loss happening to the surroundings. So it is necessary that mixing of hot and cold body should be done in such an atmosphere that there should be minimum heat loss happening to the surroundings. I mean, the full or complete heat lost by the hot body should be absorbed by the cold body. So for that purpose, we use this vessel made of copper and it is called calorimeter. Why do we prefer copper? It has two reasons. One is copper is having low specific heat capacity. Because of low specific heat capacity, when we mix the hot and cold body inside, this vessel will be absorbing only less amount of heat energy. It is unavoidable. Vessel will surely absorb some amount of heat energy, but that heat absorbed you can minimize if it is made with copper because it has low specific heat capacity. And another reason is copper is a good conductor of heat. Thereby, the temperature of this condense inside and temperature of the vessel will get equalized very soon. By absorbing a small amount of heat, the temperature of the vessel and the temperature of the condense inside will get equalized very soon. And it is made with a thin sheet of copper, means mass of the vessel is very less. If mass is very less, heat capacity also will be very less. Heat capacity formula is m into c, mass into specific heat capacity. Specific heat capacity of copper is already very low. If mass is also very low, heat capacity will be very low, means the heat absorbed by the vessel will be very less. So due to these reasons, the vessel is made with copper. And this vessel will not be kept in the open air while conducting the experiment. It is kept inside a wooden case. An outer case will be there which is made of wood. You know, wood is an heat insulator, and the space between this copper vessel and wooden case will be filled with some insulating material, so that heat from this condense cannot go out by conduction process. This insulating material and the wooden case will stop conduction. You know, heat can flow by three methods: conduction, convection and radiation. So this wooden case and the material, insulating material, will stop the conduction. The heat loss by conduction is stopped. And this vessel is copper vessel. Its outer surface and inner surface, both the surfaces are polished surfaces or shining surfaces. You know, shining bodies are bad radiators of heat. So due to shining surface from this vessel, heat will not be lost by radiation. So conduction is stopped, radiation is also stopped, and this vessel is having a lid. A wooden lid is there to close it. That also stops radiation as well as convection. From this condense, heat will not be lost by convection also. So the conclusion is this vessel is made in such a way that the heat losses by all the three methods, that is conduction, convection and radiation, are stopped. And on this wooden lid there will be two holes. One hole to insert the thermometer, because while conducting this experiment we have to measure the temperature of the contents inside. For that purpose one hole is provided. Then another hole is there to insert the stirrer. We want to stir the solution. The hot and cold body has to be mixed thoroughly so that they acquire the same temperature. Hot body will lose heat and cold body will gain heat. Finally their temperature will become same. Till then we have to stir the solution. So a stirrer is required. To insert the stirrer there is one hole here. So two holes are there on the outer wooden lid. This is about the vessel called calorimeter. With this calorimeter we will conduct the calorimetry experiments. Next topic, principle of calorimetry. It is also known as principle of method of mixtures. In this principle of calorimetry, we apply the law of conservation of energy. You have studied it earlier. Law of conservation of energy states that energy can neither be created nor destroyed. It can be transformed from one form to another form. So in this calorimetry experiments, when we mix a hot and cold body, heat is lost by the hot body. That heat, it goes to the cold body. So the principle of calorimetry says that heat lost by the hot body is equal to heat gained by the cold body. This is known as principle of calorimetry, and it is derived from law of conservation of energy. Heat lost by hot body is equal to heat gained by cold body. And it will be equal only if the heat lost to the surrounding is stopped. No heat should be given to the surroundings. Then the heat lost by the hot body is equal to heat gained by the cold body. Let us, and also remember, this is the application of law of conservation of energy. Another point, principle of calorimetry. Its another name is principle of method of mixtures. Consider two bodies, one hot and one cold. In calorimetry experiments, it is not compulsory that there must be one hot body and one cold body. Any number of hot bodies can be there, any number of cold bodies can be there. Let us discuss a simple example. In a calorimeter, we are mixing the hot and cold body. Okay. Suppose the hot body is of mass m1 and cold body is of mass m2. And specific heat capacity of hot body, suppose it is C1, and cold body it is C2. Okay. Temperature of the hot body, let it be T1. Temperature of cold body T2. You know T1 will be greater than T2 because T1 is the temperature of hot body, T2 is the temperature of cold body. So surely T1 is greater than T2. Temperature of hot body will be surely greater than temperature of cold body. Now this hot and cold body you are mixing in a calorimeter. For example, you consider hot body is a hot solid, a piece of iron, and cold body is some water, cold water. So this cold water and hot body you are mixing in a calorimeter. So after mixing it, you have to go on stirring. After some time, a final temperature will reach. You know, temperature of the hot solid will decrease, temperature of cold water will increase. Finally, a steady temperature, final temperature, suppose it is T, final temperature of the mixture. Mixture means hot and cold body, let it be T. So this T will be, if you compare T with T2, T will be greater than T2. If you compare T with T1, T1 will be greater than T. Okay. Now, in this case, apply the principle of calorimetry. How will you find out heat lost by the hot body? The formula to find out heat lost or gained is Q is equal to, this is the formula to find out heat lost or gained by a body. Q is equal to mc delta T. So how we can apply that equation and find out what is the heat lost by the hot body. Heat lost by hot body is m into mass of the body into specific heat capacity of the body into temperature change. Delta T means temperature change. So heat lost by hot body is equal to M1 C1 into delta T. Delta T means temperature change happened to the hot body. Hot body's temperature was T1 before mixing. After mixing it became T. Out of these two, T1 is greater than T. So temperature change is T1 minus T. So this is the heat lost by hot body. Similarly, heat gained by cold body. You can have, this is the formula for heat lost by hot body. Heat gained by cold body is mass of the cold body into specific heat capacity into temperature change. That means M2C2 into, what about the temperature change happened to the cold body? Cold body was at T2 degrees Celsius. After mixing with hot body, its temperature becomes T. Common temperature of the mixture is T finally. So T, if you compare these two, T will be greater than T2. So here temperature difference is T minus T2. So this is the heat gained by cold body. According to principle of calorimetry, heat lost by hot body is equal to heat gained by cold body. So you can write M1 C1 into T1 minus T is equal to M2 C2 into T minus T2. This is the principle of calorimetry. Okay, you need not by heart this equation. You remember the formula how we can find out the heat lost or gained by a body. It is the product of three terms: mass into specific capacity into temperature change. This is how to find out the heat lost or gained by a body. And you have several numericals from this topic. Usually they will give certain terms. Here you can see three terms regarding hot body is given, three terms regarding cold body, then last final temperature. In numerical, what you see is out of these terms, any one term will be missing. You have to calculate it. All the other terms will be given. We will see the numericals later. So this is the principle of calorimetry. By applying principle of calorimetry, you can find out specific heat capacity of a solid. Let us discuss that experiment. This experiment is just for understanding. You will not get a question like write an experiment to find out specific heat capacity of a solid. To solve the numericals, you must understand this experiment. That's all. Suppose a solid is given to you and you are asked to find out its specific heat capacity. You can conduct a calorimetry experiment. For that, you need a calorimeter and that solid, the given solid, you have to find out the mass of the solid. Let it be M. The given solid is of mass M and its specific heat capacity we want to find out. First you find out the mass of the solid. Then you keep that solid for heating. By any means you have to heat the solid to a high temperature. So you keep it for heating. Many devices are there to heat in a different way. That devices we need not bother about. Keep the solid for heating. By the time you get a calorimeter, empty calorimeter. Calorimeter is always accompanied with a stirrer only. So whenever you have to find out the weight of the calorimeter, stirrer is to be accompanied. So get an empty calorimeter with stirrer and find its mass. Mass of calorimeter with the stirrer, that is understood, stirrer will be there. Empty calorimeter. Let it be M1. In your book, the symbol, by mistake they have written M2 on page number 242, last line. M2 you have to make as M1 because in calculations they have used it as M1. So M1 is the mass of this empty calorimeter. Its mass. Now half of the calorimeter you have to fill with the normal tap water, I mean water at room temperature. Find out the mass again. So you will get the mass of calorimeter plus water. Let it be M2. Then measure the temperature of this water, initial temperature of water. You know temperature of this water and vessel will be same. It can't be different. This vessel, calorimeter and water, its initial temperature you want to measure. Initial temperature of calorimeter and water. Let it be T1 degree Celsius. Remember it is ordinary tap water and its temperature is T1. And now measure the temperature. We are going to add the hot solid. Suppose this is the solid which we have kept for heating. Its mass already we have measured. Now we are going to drop this solid into this water. Before dropping, find out what is the initial temperature of that hot solid. Let it be T2 degree Celsius. So you know T1 and T2, if you compare, T2 will be greater than T1. T1 is the temperature of normal tap water. T2 is the temperature of the hot solid. Now drop this solid into this water. Remember the solid is a hot solid and water is tap water. So after putting the solid, go on stirring the solution. You will see temperature goes on rising because the hot solid is losing heat. That heat lost is absorbed by this water and vessel. Water and vessel are cold bodies which are absorbing heat. Solid is losing heat in this experiment. Thereby the temperature of this contents will be going on rising. Finally, it reaches to a steady temperature T. That is the final steady temperature T. You know T, if you compare with the T2, T will be less than T2. T, if you compare with T1, T is greater than T1. Okay, so these are the readings we have taken. So in this experiment, there are three bodies involved. One is calorimeter, the other one is water, and the third one is solid. These are the three bodies involved in the heat transaction. Out of this solid has heat loss and these two are having heat gain. These two are cold bodies in our experiment. Solid is the hot body. Hot body will have heat loss and the cold body will have heat gain. So we can apply the principle of calorimetry. Heat lost by the hot body, that is solid, is equal to heat gained by the calorimeter plus heat gained by water. Two bodies are absorbing heat or gaining heat, one is losing heat. So you can write the next step. Heat lost by hot solid is equal to heat gained by calorimeter plus heat gained by water. According to principle of calorimetry, heat lost by hot solid is equal to heat gained by calorimeter plus heat gained by water. Heat gained or lost, the formula is mc delta T. This is the formula to find out heat lost or gained. So how will you find out heat lost by solid? That is mass of solid into specific heat capacity of solid into delta T of solid. So out of these three substances, calorimeter its specific heat capacity I am writing as Cc, specific heat capacity of calorimeter. This is specific heat capacity of water Cw, specific heat capacity of solid Cs. These are the three symbols I am using for specific heat capacities. Out of these, These two will be already non-values, and this specific capacity of solid we want to find out. This is the term we want to find out. So heat lost by solid we can find out by the formula mc delta T. Mass of solid, already you know m into specific heat capacity of solid. We are using this formula Cs into what is delta T for the solid. What is the temperature change happen to the solid? Solid was at a temperature of T2. From there it reaches to T after mixing with water. So T2 minus T. That is, this is the formula to find out heat lost by solid. It is equal to heat gained by calorimeter. Again use the formula mc delta T. Calorimeter, its mass is here m1. Specific capacity here. So m1 into cc into what is the heat gained by calorimeter? Temperature change of the calorimeter delta T. Calorimeter was at a temperature of T1. Finally it becomes T. You know T is greater than T1. So here T minus T1. That is the delta T or temperature change happened to the calorimeter. Plus heat gained by water. Again the formula mc delta T. Mass of water, how will you get? That is m2 minus m1. m2 is the mass of calorimeter and water, and calorimeter alone, its mass is m1. So m2 minus m1, that is the mass of water, into specific capacity of water into what is the temperature change or delta T of water. Water from changes its temperature from T1 to T. T is greater, so T minus T1, same is the temperature change here. So from this equation, except this Cw, specific heat capacity of solid, this is unknown. All other terms you will get from the experiment. So in this equation you can find out what is the specific heat capacity of solid. This is the experiment to find out specific heat capacity of a solid. Now if you want to find out specific heat capacity of a liquid, you can conduct the same experiment. Only one difference is there. Instead of water, you have to use the liquid whose specific heat capacity is to be found out. Conduct the experiment as it is. Okay, and you instead of water, use the liquid for which you have to find out the specific heat capacity. And the solid which you are choosing, remember, it should be insoluble in the liquid. Such a solid you have to choose. So conduct the same experiment. So, and you will get the same equation. Heat lost by the solid is equal to heat gained by calorimeter, and heat gained by, instead of water, liquid. Here also liquid. Here liquid. So here in that case, this specific heat capacity of liquid will not be given. The other two specific heat capacities will be given. These two are already known. Specific heat capacity of the liquid will be unknown. So in this formula, same equation you will get. This will be unknown term. Specific heat capacity of liquid will be unknown. All the other terms will be known, and you can find out the specific heat capacity of the liquid also. Okay, we will continue the remaining numericals and all in the next coming videos. Okay, thank you.